All right, am I here? Can you hear me? Hello, hello? Okay. Mm-hmm. All right, so let's try, what are we doing today? Okay. Hi, everyone. How's everyone doing? Can you see me? Can you hear me well? All right, I don't know what I am. Okay. Mm. All right. I think we are ready to start. Sorry, I have a lot of stuff going on right now. So I apologize for that, but I think we might be able to make it happen today. Good morning, everyone. Very happy to be here as usual. A little bit strange, yes. Self audio is a little bit strange because I'm not using my microphone today. And I'm also in a room that is basically empty, so it's a little echoey. But we're gonna have to deal with that today. So there's really no work around that. Welcome everyone. So very excited to be here as usual. So as many of you know, this live stream was going to happen yesterday, but it didn't happen because I had technical difficulties. But what we're going to do today is that I have had the chance to basically borrow a robot for about a week or two, and I have it in my apartment. And I would like to thank Dr. Merritt Moore, and I would like to thank Universal Robots, and I would like to thank the Harvard Graduate School of Design for making this happen. Okay, and I thought that it would be an interesting thing to just make a live stream where we can specifically as a community, I can teach you a little bit of how controlling a robot in real time works, and also show you some of the new tools that I have developed and give all of you here in the live stream an opportunity to remote into the robot that I have here. So I have put together a lot of things. It's like a castle of technology that is very fragile. So I'm sure everything is going to fail catastrophically. But we're going to give it a try. So what we're going to do today's going to be a bit of a special live stream. I'm not going to be teaching that much because I would like to give you the opportunity to play a little bit with the robot. So it's going to be based on a Zoom call, all right? And if you wanna, I'm going to post the link to the Zoom call that we're going to be using. We're going to be using a Zoom call because for those of you who are going to be connecting to the robot, I need to give you, I would like to have real-time back and forth with you. And if we do this through YouTube, it's going to have a lot of lag. So I'm going to be posting on Discord right now. I just posted on Discord on the live channel, the link to the Zoom call that I am at right now. So if you want to join that, please, oh, I see we have people already. The, Let me turn off the audio for people joining in. All right, yes. Okay, so I start seeing people joining in. Hi, Arasto. How are you doing, sir?
How are you doing? I'm fine.
Okay, so for those of you who might be new to the channel, we have a Discord. I posted the link somewhere on the YouTube chat before. So if you want to join us on the Zoom call and then get to play with the robot, please go to the Discord and go to the live channel, and then you will find the Zoom link there and you can openly join. Okay? So that's one thing. The other thing that I would like to do is I have another computer here, so I'm going to connect that computer so that we can all see the robot. So that computer is just going to be streaming basically the robot. Let me make that happen. So I'm going to join that meeting with my side computer. All right. Okay. And then how do I rename myself? Yes. You are 10. And then this thing should have. Okay. Ooh. There you go. Oh, and it's me. Hey. How are you doing? All righty. Okay, and this thing has audio. Andres, I see a lot of known people. Hi, everyone. Victor, Said, Salvador, Andres. How's everyone doing?
Amazing.
Okay, and I see. All right, let me refocus this camera a little bit.
Hi everyone. Hi Arasu.
Hey, Said, what's up?
Good man. How's it going?
All right, it's not great, but it will do for the time being, hopefully. All right, that's one thing. Okay, so that's working. Okay, so we have one thing working. That's great. Now,
Oh,
okay.
there's there's a lot of delay between the Zoom call and the YouTube channel.
There is, yes. That's why it's not great for real-time stuff.
Mm.
Okie dokie, so that's great. So that's working. And also, for those of you who want to join and tinker with the robot today, I have posted a zip file on Discord. That zip file contains a version of the Machina for Grasshopper plugin that has a couple modifications that you're going to need if you want to connect your Grasshopper to the robot here today. So if you can please go ahead and delete whatever Grasshopper, Machina for Grasshopper you had on your system and substitute it with the nightly version that I have posted on Discord, then you will have the option of working with us today, okay? And I also included 2 sample files that you might be able to use today as well, okay? All righty, so who's on the call? Oops. Oh, there's a lot of people in the call, nice. Okay, and so for those of you who are joining the call, just so that you know, if you turn on your camera, you will show on the YouTube live stream. So if you have, whether if you want your face to show up or not, is absolutely up to you, okay? But just make sure that you understand that if you turn on the camera, your face will appear on the live stream, okay? Which I like, but I understand that's not everybody's cup of tea. And let me turn on the robot too. The robot is not on. I hope the robot works today. All right, there you go. Okay, and let me check real quick that the robot is actually working. So I'm going to remote into the robot. And I'm going to choose one. Okay. And it looks like it's connected, so I'm going to move the robot down a few millimeters. And yes, you see the robot moving down? All right. So that's good. So it means the robot is working. Okay, so I'm going to move it up again then. Back up. There you go. All right. So I think we're ready to start formally. I can see in the chat, how do we join? I don't know if it's on PC, but I can't hear anything. I think I think sound is good on my end, otherwise. So, okay. So we're going to. All right. Okay, so I think we are good. All right. So let's start. So, hi everyone. So this is Jose Luis again. This is Parametric Camp, and today we're going to have a community call. We are joining on Zoom, so if you want to join the call, please go to our Discord channel, which is on the YouTube chat, and there's a Zoom link to the call that we're in. You will need that if you want to play with the robot a little bit today. And also, if you want, I just posted on the Discord channel a zip file with a version of the Grasshopper plugin that you will need to use if you want to play with the robot through Grasshopper as well, and a couple of sample files. All right. So, what are we going to do today? Let me give you a little bit of a small lecture, okay? Because you know, it's the professor in me. So let's do a little bit. All right. So, okie dokie. So, what are we going to do today? So, let me first thank. Where is the? Can I draw the screen? Yes. So, oh, oops. All right. So first of all, I was going to do a presentation, but I didn't have time. So I would like to thank Dr. Merrick Moore, who is the art and choreographies. So I would like to thank her. I would like to thank Universal Robots, and I would like to thank the Harvard Graduate School of Design for making this live stream happen, because it was through them and through their help that today I have a robot in my apartment, and that I'm able to share this with the community. Okay, so that's very important. Now, what? All right. So now, what I would like to share with you today is that many of you know that one of my pet projects, or one of the things that I have contributed to the community in the past, is this library or this collection of tools called Machina, which is specifically designed for programming and controlling industrial robots, and specifically with a very strong focus on real-time control. All right. And many of you might be familiar already with the framework. There is this one application called Bridge. There is plugins for most of the most common environments for designers, like Grasshopper, Dynamo, processing, Python, C Sharp, all the cool things. Now, the way this typically works is that typically we have a robot, something like this, and we have a robot that we want to control in real time. So typically, the way we do that is with the Machina framework is by connecting that robot in real time with this application that is called the bridge. Okay, and then the bridge is basically a Windows application. I'm going to write that here. It's the Windows app. It's a Windows application that we use to control the robot in real time. So for example, let me show you an example of that. I'm going to open the bridge here, and I'm doing it from my development environment so that if something fails, I can see where the error is, etc. But, and actually, let me see if we can see the robot from this call here. So, my computer is about to blow up, I think. Okay. Yes, we got the robot there. So hopefully you can see the robot here on my screen, and you can see the bridge here on the end. So the way the bridge works, the bridge is a console, is like a terminal-like application that we can use to, for example, to select, I want to connect to a new robot, and the IP of this robot is 192.168.0 and 110. So I'm going to connect to this robot, and things went well. And now, what I can do is I can dock this on the side and say, well, let's see if the robot, is. There you can see the robot. All right. So what I'm going to do is I'm going to move the robot. For example, I'm going to move it a little bit below, so -200 in the Z direction. So that's it, pointing down like that. So I'm going to do that, and you can see that as I type the instruction here on the terminal, the robot goes down. Maybe now I'm going to move the robot in the Y direction, which is that direction. So I'm going to move 0, 100, and 0. And as I do that, the robot moves in that direction. I'm going to speed it up a little bit. So speed 2, 100, and that's a little too much, 50 millimeters per second. Now I'm going to move it up. So that's going to be 200 in the positive Z direction. So that's going to be that one. You see now it's a little faster. And now I'm going to rotate it around the Y vector. Y vector is pointing there, so I'm going to rotate it like this. So that's going to be rotate around the Y vector, so 0, 1, 0. And I'm going to rotate -90 degrees. So -90 like that. And you see that the robot is slowly rotating that way. All right. And now I can also move it in the X direction. So 100, 0, and 0. Right. Now it's moving that way in the X direction. And if I want to bring it back home to a relaxed position, I can say, well, for universal robots, I can set the values of the axes, all the joints, in degrees. And for universal robots, that position that we had before, that position that we had before where the robot was like this, that is 0, -90, -90, -90, and then 90 and 90. It's a little complicated for universal robots, but it is what it is. So I can now bring the robot back home, and I can disconnect from the robot. Okay, so everything that you have seen here, just a warning. I am not really looking at the chat on Zoom, so if you have questions, please post them on the YouTube chat, because otherwise I really don't have. It's very difficult for me to read the chat on Zoom right now. So what I just did was controlling the robot in real time from my machine. Okay, so because the bridge has a small terminal and a small console, I was able to type in this tiny console here the instructions. All right, and then those instructions get sent right away to the robot, and then they get executed. Right. However, this is cool for prototyping. It's cool for really basic motion, and it's cool for learning. But it's not very often useful for production. So when we want to do larger programs, or where we want to write smarter programs that can react and can respond to the robot. So one of the interesting things about the bridge, all right, is that it also has in the back end, it has what's called it allows for other applications to talk to the bridge, just like I have done by typing in the console commands. It allows other applications in your system to send those commands directly to the bridge. So what that does is the bridge has this thing in the back end called a WebSocket server, all right? And that WebSocket server, what it does is it allows other applications to connect to that server and to send instructions. So for example, if I have a Grasshopper application, if that Grasshopper application has a, oops, what am I doing? If that Grasshopper application has a web socket client, then this WebSocket client can communicate with the bridge back and forth and can send instructions. Can move, rotate, all of those stuff. So for example, let me show you an example of that. Right now we have the robot. I'm going to connect the bridge to the robot again, and I'm going to open Grasshopper. In Grasshopper, I'm going to drop this program called Simple Program Vertical Square, all right? And that is a program that has all these Machina actions: speed, radius, axis, send a message, send the joint motion, etc., etc. It has basically, I have created basically a large list of actions that I have compiled into a list. So I want to set the robot, the motion, blah, 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 etc., move, wait, and then go back home. And then what I'm going to do now is, you can see that here I have a way of connecting to the bridge, all right? The bridge is using this address by default. So if I double click here, you can see that I just connected to the Machina bridge, and I can see that on the clients, I have my Grasshopper here. And if I now take the program that I just created, this one here, and if I send it as a batch to the bridge by pressing here this button, you're going to see that all those actions are going to pop up on the bridge, and then the robot is going to start following them one at a time. So I'm going to do that. I'm going to click here, and as I click, they show up there, and you can see that the robot just moved to this position, and it rotated. It was actually very fast. That's kind of scary. And then the robot is going to move up, and it's going to trace this vertical square, and now it's going to go back home. All right. Woohoo! Let me do that again, because it was cool. You see, the robot goes there, it rotates. Now it's going to make this small square in the end. This. There you go. There you go. And it's going back now. All right. And a similar program, so for example, I'm going to disconnect from here, I'm going to close this program, and I'm going to open the other one that you have in the sample files there, which is called Robot Motion Control Panel. What this does is a very simple program. It's more, imagine a control panel if you wanted to control the robot and tell it to move to the right, to the left, etc., just with individual instructions. So what we can do here is I can connect to the bridge by pressing here, connect, and you can see that there's a Grasshopper client connected now. And here I have a bunch of options: the precision, the speed, and the distance. So, and what I'm doing here is that this Grasshopper definition, the only thing that it has is it has a bunch of components that send actions to the robot. And then whenever I press each one of these buttons, so if I press move back, then the robot moves back. If I press move left, and actually it's not working right now. So for some reason, am I connected? Let me check that out. Let me see if I am connected. I am connected to the bridge. And what is the action that I'm sending? Move. Set initial parameter. Okay, so this is not working. Great. The sample file that I shared is not working for some reason. I wonder why. Okay. All right. I think this might have to do. So I'm going to reconnect again. And then I'm going to try sending this now. So I'm going to, where is the robot? The robot is here. So I'm going to say, send initial parameters. Yes, now move down. Now move up. And now move down and up. Down, 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 down. Up, 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 up. You can see how the actions are showing up here on the bridge. And now move back, move left, move right, 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 down, left, back, left, left, front, front, up, up, down, down. And as I press, all those actions start going on the buffer. And then, so basically we can control the robot in real time by pressing a bunch of these buttons here in Grasshopper, which I think it's also kind of cool. So this is the basics of how you can do real-time control in in a very simple way with Machina as a standalone application and as a plugin for other applications such as Grasshopper. I see a question from Victor. Are movements limited to single movement, or can multiple targets be defined with blending and zoning? So you can send a full list of targets, Victor, and then you can define also blending and speed. It's just that instead of defining speed and blending for the target, what you do is you define those values in general, and then any motion that comes afterwards will follow those values of speed and blending. Okay? All right, but what I would like to show today is a couple of things that I have improved in this whole system. And it is the fact that, well, this is great as we have it right now, but obviously this is all working locally. And the idea is that for this setup to work, your bridge application needs to be on your machine, and your Grasshopper application or whatever other client you're using also has to be on your machine. So, so what I'm going to show today is how this new thing that I've made, which is, let me move this somewhere here. Yes. So so that we can work with this from remotely, what I have developed recently is, let's say now that we have our Grasshopper application here. But the Grasshopper application lives on a different computer than the one on the bridge. Making that connection between those two, if they live in different computers, is kind of difficult because since they are different local networks and they have to go through the internet, there are some hurdles or some like special configurations that sometimes you need to set up. And actually, I see that Kunaljit from the IAC, from the Institute of Advanced Architecture in Catalonia, he's on the call right now. And they actually, for example, were successful in making this happen. They were successful in using the bridge for allowing their students to remote into the robot by doing some special network configuration on their end, some port forwarding, etc., which is a good way to go. It just requires that you have control over your network and that you know a little bit of what you're doing, which you should always know what you're doing, but I would like to present today an alternative way of doing that, which is perhaps a little easier to set up, and it doesn't require modifying your network at all. The way we're going to do that today is I wrote this new thing called the Machina Server. All right. And the Machina Server is basically a WebSocket server. So I'm going to do this here. It's a WebSocket server, and then this lives on the cloud. This whole thing is machine 1, and this other one here is machine 2. Okay? And then what we're going to do is that now, instead of Grasshopper talking directly to the bridge, because they're in different machines, this is actually very difficult. What we're going to do is we're going to use our clients, and what we're going to do is we're going to connect Grasshopper or any client, we're going to connect it to the Machina server, and then whenever there is a move instruction, for example, that instruction is going to be broadcasted to the Machina bridge, who is also connected to the same server. Because these both have now a WebSocket client, and this also has a WebSocket client. This diagram is ridiculously ugly. I hope you forgive me about that. But yes, and then this is going to allow us to also, for example, control the robot from other applications, like for example, a web application, which I'm going to share with you in a second. So for example, how are we going to do that? Let me show you. So here I have this thing called the Machina Server, all right? And I have the thing called the Machina Server. It's a program that I wrote in glitch.com. It's actually open source, so you can check it out. I'm going to paste it on the Discord. Hey, Said. I'm going to paste it on the Discord in case you want to check the code, but it's not necessary to know the code. All right, and then what we're going to do is I'm going to share with you this other application that I have made. It's a WebSocket. It's a remote terminal. Okay, what this means is that with this terminal is an application. It's this one here. All right. So what I've basically done is I have written a front-end web application that looks like the terminal. So it asks you for information on how to connect to that robot, and then it allows you to write input here. So let me first connect the bridge to this server. So I'm going to connect the bridge, and I'm going to say, well, instead of here, I'm just going to type here Machina server.glitch.me. And I'm the key. I'm going to use a secret key, right? And I'm going to try to connect here, and then let's see if this works. Because obviously we're doing live, so it's probably not going to work. I did, yes. So the bridge is successfully connected to the server. All right. And then now what I'm going to do is I'm going to try to connect the client, this terminal, to the server. So this is going to be pcam that I'm connected, and the authentication key is going to be this one. I'm going to connect, and you can see that I just connected here. So now I can send instructions to move a little bit above, and you can see that it goes to the bridge, or for example, move in the X direction. All right, and then I move down, and then I want to move down. All right, and I'm going to move back to where I was. All right, the interesting thing is that even though this is living on my machine right now, oh, I see someone is sending stuff. Oh, wait. I don't want anybody to control this while I'm I see that someone is already sending stuff here. No, I'm not going to, no. So I would like to wait for all of us to play with this together, okay? So, but what you can see is that what's interesting is that this remote terminal lives on the cloud as well. It doesn't live on my machine, which means that anyone can use this tool to connect to the bridge, all right? Which is what we're going to do today. So I'm going to share the link to this on the Discord so that you can all access the terminal and then you can use it, all right? I have disconnected the bridge right now. If you want examples about what kind of programs you can send to the bridge, there's also some documentation here. So if you click on more samples, blah, 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 you will be directed to like an explanation of the basics of the Machina common language, which is these things that we're typing. And you can see very basic examples of a program that traces a square, changing the speed, changing some parameters, moving, rotating. And all of these programs are programs that you can copy and paste them here on the terminal. Okay. All right. So what are we going to do? What I'm going to do right now is I'm going to open it up to whoever wants to participate and whoever wants to try to control the robot in real time. Okay. So the way we're going to do that is we're going to do it through the remote terminal that I just posted on the chat. Okay. So if you want to do this, send me or unmute yourself and tell me like, hey, can I give it a try? And then I will start up the bridge again and I will send you the key in a private way so that you can connect to the robot. All right. So who is interested in giving it a try? Just unmute yourself on the call and let me know that you're interested.
So yeah, I'm interested. I'm Arastu here.
All right, Arasto, let's give it a try. So what I'm going to do is I'm going to privately send you, the key that you need to use to connect to, all right? So for example, I'm going to connect to the robot, and then here I'm going to say, this is going to be, all right. All right, and the key, Arasto, is going to be this. This is the key that you need to put in the terminal, okay? Sorry, this one. Do you get it from the Zoom chat?
Yeah, I did.
All right, so connect, use the terminal to type here the key. Okay, I see you're connected and you are connected to the robot right now. So whatever you type on the terminal is going to go to the robot. And don't worry if you do something. If you do something that you shouldn't, I have an e-stop here on my end, so I can stop the robot.
Okay, so by the way, it's in millimeters, right?
Excuse me?
It is in millimeters. So
Everything is millimeters, yes.
Hey, it's okay.
Yeah, that was you, man.
Yeah.
Yep.
So let's say, what's the coordinate of the machine right now? So I'm gonna send it to move to,
Which
let's say 800
yeah.
minus 200, and let's see what 0 does.
No. Zero's on the table.
Oh.
Yeah.
Okay.
0 is the table because C0 is so 000 is the center of the base of the robot.
Okay.
So if you do Z0, then this is going to try to be at the same height as the table.
Okay, so
let me connect again. And all right, so now you got it.
Do I need to reconnect?
I'm not sure. So just try sending again.
Yeah, it works. Right. So this time
yeah, I'm sending it. It's good. It's good. It's going to stay close to the top of it. You see? Close to the top. It's like it's 300 millimeters above the surface of the table.
Okay, so I'm going to move it right back up about like 500 millimeters.
Very good.
And what I'm going to do right now is to give it, I'm going to make it follow a square. Let's see how that's going to work. So 300 in the X, and then again, go minus 300 in the Y, and then all of these go minus, and just like that. So I'm sending a bunch of commands at the same time.
All right. I think you might be pushing a little too far away. All right.
Yeah.
Yes.
Yes, it is.
Yes, it was too far away. So yeah, don't worry. The bridge will not prevent you from moving it to a position out of reach. That's on the works. The developer has not gotten there yet, you know.
Yeah, I know. I know what you mean.
but it will happen at some point. Okay.
Yep. Mhm. Yeah, awesome. I mean, I'm controlling the robot right from Japan
From
in
Japan.
the United States, like across the globe. Like, cool.
Oh.
This is cool.
Another thing you may want to try. So if you go down on the terminal, if you click on more info and sample programs, you have all these sample programs that you can copy paste on the terminal. So you can do like a bit more complex.
Okay, so let's see what this does. So can I send it?
Yes.
All right.
Move to, so you're sending coordinates to a location somewhere in the space. Then you're going to wait 2 seconds. You're going to move up, wait a couple seconds, and then go back. All right.
It is
Sounds good.
exactly how it works with the Machina Bridge terminal.
Sorry?
I mean, it looks exactly like how you would work with the Machina Bridge, the terminal right here on the right of
Exactly.
the
Yeah.
bridge itself.
That's the whole point. Like giving the same experience, but just giving it remotely. Which
Okay.
also full disclaimer, there's a lot of safety issues here I'm concerned. We're doing this because I am here and I have an emergency stop button that I can press anytime. If it's not a safe thing to do this if you cannot stop the robot with an emergency control, okay? So don't try this at home or don't try this with someone else's robot if there's no one. All right, all right, so you sent another program, it rotated, now it's going to go up, and then it's going to then rotate back home, correct?
Exactly.
There you go.
This is
Woohoo!
so cool.
All right, Arasto, do you think it's time to give it up to someone else?
Yep, thanks so much. It was amazing. Thanks.
No problem. Who wants to go next? Any volunteers on the call? Come on, don't be shy. You're more than welcome. Am I still on the call? Alrighty. Who would like to go now?
It seems like Victor wants to go, but he says that he doesn't have a mic.
All right.
So yeah.
All right, Victor, I would like if I'm going to give you a couple minutes to see if you can figure out a microphone from your laptop because I would really want to have audio so that we can talk and we can go through problems. So let me give it up first to someone else. And if you can really try to get a microphone, because I will feel much safer if we had voice to communicate with each other. Are you okay with that? What is in the chat? Okay.
Yes.
All right. Anyone else who's up for this? Oh, come on, don't be shy.
Okay, I can. I won.
All right, Salvador.
Thanks.
How are you doing, sir?
Fine, thank you. And you?
I'm
Everything's
doing
fine.
well. I'm doing well. So, all right, so I'm going to create a new key for you.
Okay.
And then I'm going to reset the bridge to that key. All right, and I'm going to send you the key privately on Zoom. All right?
Okay.
I think you're going to like the key.
Yeah. Nice key.
Yeah.
Well, okay, I will try to connect. Is the same name, the same server URL?
Yes.
And just change. Okay.
Just change the key. Exactly. I see you're connected. You're Jane Doe, right?
Yeah.
All right. Good. So I think you're on. The robot is yours now.
Thanks. So the input. So then I can, in just in input, I press enter or
You press Control Enter.
control enter. Okay.
Because you can send multiple programs at the same time. Yeah, that's you.
Ah,
You're
cool.
moving in the right direction.
Nice. Yeah. Can I give a try with rotate?
Yes. Do you know how it works?
I will try it. I just try
Yeah.
to put all the okay.
Very good. It's just a positive 90 is rotating it that way. So how about you send now rotate the same one, but rotate minus 90 and you send it 2 times so that it untangles like that way. You see?
Yeah.
So send the same one, but with minus 90 and send it twice.
The same one, but just could you repeat again? Sorry.
Yes. So you know how you just send a positive rotation in the 90 degrees?
Yeah.
So can you send a rotation in negative 90 degrees?
In negative 90 degrees. Okay.
Yeah, so that it rotates back.
Okay.
And can you do that twice so that it ends up facing that way?
Okay. Just the same 0, 1, 0.
Yes.
And then negative. Okay.
Negative 90 and just do that twice. There you go. And another one.
2 times. Yeah.
Yeah, another one. Because the thing is, if you do 180 degrees, the robot doesn't really know which direction to go. That's why it's better to do 2 times minus 90. Oh, no, you said positive again.
Oh, sorry.
No, it's okay, it's okay.
the bad thing about just copy and paste.
I know.
Cool. This is awesome.
All right. So if you want to send something, but you're still not, okay, so let me help you here. Or I don't need to help you. Would you want to rotate it back to where it was before?
Okay.
There you go. And send that same one, the negative 90. Can you send it again? There you go. So now it's going to end up facing that way. And if you wanna copy and paste and send a bit more of a more complicated program, just go to the examples, and then you can copy paste one of the examples and send it.
Okay. In samples, right?
Yes. Victor, how are we doing with the microphone?
Does this work?
Oh, it works. Hi, Victor.
Okay.
Hey, Victor.
Hey. Quick question. Is the movement linear or is it like joint?
Oh, very good one. So you can choose. So Machina has this command, so you can set motion mode, and you open parentheses, and you type linear with semicolons. Can you see it on the screen? And if you do that, any motion after that is going to be linear. But if you say motion mode, and then you type here joint, then any motion after that will be a joint motion. And you can always switch back and forth whenever you want. Does that answer your question?
Yeah.
All right, wonderful. Salvador, do you feel complete, or do you want to send a goodbye message to the robot?
Okay. Well, last one, I just copy and paste another sample. So
Yes.
can I give it a try? Okay.
Yep.
The last one. Yeah, thanks.
Yoo-hoo! All right. Oh, I think that might not work.
Oh.
No, it's gonna work. It's just that when it rotates, it may rotate into itself.
Okay.
You see now it's rotating? You see, is it gonna hit itself? If it does, it will stop. So will it? No, it's actually fine. All right. So now it's going to move up, right? There you go. Oh, that's kind of a nice move. And then it's rotating back, positive 90. And then it's going to go back home, kind of. Oh, that was a beautiful movement, Salvador.
Thanks. It's in the samples.
All righty. Okay, Victor. Thank you, Salvador.
Thank you.
Victor, I think we're ready for you.
Okay.
Yes, I'm going to send you a private key over the chat, okay? Over the chat on Zoom. So where are you? You are here. So the key is going to be this one, okay?
Do I have to put any input?
So wait, what? So I see you are connected. So now you are connected to the robot right now. So now you can type on the input box, and any action that you type will come here to this robot.
Okay, so currently is the rotation 000, or what is this right now?
Right now, the robot is pointing down.
Okay, so if I do a transform 2, and then my x is 200, y is 0, z is 200, and then my rotation is 0.
I think 200 is going to be too close to the robot base. So maybe you want to do transform 2. There are here on the samples, there are a couple samples of transform 2s. You see them here?
Yeah.
Transform 2s that will work for this robot. So if you want to try those out, transform 2 is a complex motion that does both moving and rotating at the same time. And the way you control that is, this is the X, Y, and Z position where the robot will end. This is where the X vector will be pointing. So for example, the X vector in this robot right now here is pointing this way, okay? So if in this code here, if the robot is pointing at 0, 0, -1, it will mean that you will move the X axis so that it points down in -z, okay?
Okay.
And then the same here, this is the Y vector, which is this robot pointing this way. And if you make it point in the Y direction, then you will basically not change anything. So give it a try.
Okay.
Oh, what is going on? Yoo-hoo! Okay, stay there. So look at what happened, because you set the X vector to match the X vector of the flange to match the X direction of the world. Now the X vector, which is here, is pointing this way. And the Y director is pointing that way. So that's why it went upside down. Remember that.
Okay.
Yes. So now if you type the same thing, but you flip the direction of the X vector, then the robot will try to just rotate like that. So send the same action, but flip the direction of the X vector. So instead of +1, it's -1. Oh. Uh-oh.
My bad.
No, it's not your bad. It's that the robot is too close to the table. So I think in trying to do that rotation, it was going to hit the table, right? Which is fine. This is what happens when we are learning things. Don't worry. So what I pressed the emergency button and I stopped the robot, so nothing happened. Don't worry, Victor. Okay. So now what we're going to do.
On collision, what happens?
Well, this robot will know that it has collided and it will stop. But it's not a good thing. It's bad for the brakes, it's bad for the joints, and maybe you can hit the table and make some damage to the table. And if you hit a human, it will definitely hurt. But the good thing about these particular robots, universal robots, is that they are designed to be safe around humans. So the robot will know that it has hit you. It will hurt you, but it will stop. So it won't be a serious injury, probably. Okay. So I'm going to now, because I pressed the emergency button, I need to manually restart the robot. Okay. So I'm going to disconnect everyone. I'm going to now disconnect from the robot, and I'm going to try to untangle it. All right. All right. The way I'm going to do that is by setting the axis to the values of 0, minus 90, minus 90, minus 90, and then 90 and 90, which is home for this kind of robots. And as I do that, the robot just elegantly goes back to its home. All right. All righty. Victor, do you feel complete, or do you want to try anything else? Something else?
Give me like 5 seconds and let me set one more.
Okay, let me then connect you again, because right now you are not in. Are you connected? You may need to connect again, Victor. Yes, there you go. Okay, so the robot is ready for you.
Okay, hold on. What's the home axis joint angles?
It's axis 2, all right, and then 0, minus 90, minus 90, minus 90, and then 90 and 90. That is specifically for universal robots. For ABB or for KUKA, it's different. You see them on the screen?
Yep. I'm going to try this.
But I think we're gonna, oh, I see what you're doing. So you're going to go, and then it's going to go up and rotate backwards. Ah, nice. Okay, let's see if it goes. So right now it's moving up while it's also changing directions. You did that on purpose, right?
Yeah. So for example, right now it's in linear mode.
Yeah.
So then at the very end, I'm getting an axis angle. So would it change to a joint movement, or would it somehow interpolate from the angle?
It interpolates between the angles. Yeah. All right, so we hit an emergency stop because the robot, as it was trying to rotate, it was going to hit itself. So the robot stopped. All right, so I'm going to disconnect and connect again, and I'm going to untangle it. All right. Okay, and we're good. All righty. Thanks a lot, Victor.
Yeah, that was fun.
Thank you. All right, I want to show you guys something else. So I wrote the terminal part, okay? So with the terminal, you can just go here and type your instructions, etc., and it feels like you're using the bridge, but you're using it remotely. However, what's cool about this system is that we can use it from the web app, but we can also use any other application to connect to the same server and to connect then to the bridge. So for example, I have the robot here, okay? And remember how, well, let's see, where can I go? I'm just gonna leave this here. And so, I have a lot of stuff here. Wait. So, yes, so for example, something that I can do is I can say, I'm going to disconnect from here. And now instead of connecting to this URL, which is the URL for a bridge that is living locally on my machine, that's why the 127.0.0.1, instead of that, I can connect to the server that is living on the cloud. So I can use that as the URL. I can just plug in here some key, for example, robot key, and then I can use that to connect to the bridge. So for example, you're going to see here, this is a server. So if I connect here, I think the server is being a little slow today. All right, can you see how client Grasshopper just connected? What is Grasshopper? Yes, so Grasshopper just connected to here, and I can now fire the bridge, and then just input here the same key, reset the bridge. You can see how the bridge connected, and now they're both connected to each other. So if I connect the robot now I have this Grasshopper instance is connected to the bridge, but it's connected via the cloud. So why is this? Oh yeah. So you can see, for example, I can move down, I can move up, I can press the button and move back, left, and right. But the interesting thing here is that I'm not doing this directly from Grasshopper to the bridge, but I'm going through the server. So if you move up, you can see that all these instructions have been managed through the server, which means that any of you remotely can also use this Grasshopper definition to connect to the bridge and to connect to the bridge and to control the robot remotely. The terminal or doing it through Grasshopper, both are going to work. Okay? So who would like to go next from the call? Anyone interested? All righty. Well,
I'm interested, but I went once, so will it be okay for me to go again?
yes. Let's give it a few seconds in case anybody else wants to jump in. But otherwise, you're welcome to try again if you want.
Yeah, of course.
All righty. Okay, well, it looks like we don't have any more volunteers. So Arasto, you're more than welcome to jump in again.
Yeah, thanks. So do I need to connect with the same key?
I was about to tell you right now. Yes, I just entered the same key that we used before.
Okay, so.
And you look connected from Grasshopper, right?
Yeah, but I want to say.
You just disconnected.
Yeah, I want to personalize it. Okay, right. Okay. So let's say relative What does this do? Okay.
Wow, is that you?
Yeah, it is.
Nice.
So cool. So yeah.
And what I love about this is that you're literally on the other end of the world right now.
Yeah, literally I am. Like here it's like 12 a.m. Like it's 12:15 a.m. in the like in the
So
night.
13 hours difference.
Yeah, it's a 13-hour difference. And once I click on the button, it almost does it instantly. I mean, it's like as if it's right beside me.
Yeah, WebSocket is pretty nice. WebSocket WebSocket communication is pretty decent. It's not maybe like real time as UDP can be, but it's pretty good for these kind of things. It works perfectly. It's what all
Yeah.
chatbots and things like WhatsApp and WeChat and all those things are based on.
And to think of it, it's all just JSON files and text. So
Yeah.
it's not like we're sending anything in particular.
No, it's just JSON. It's just text in the form of JSON files. And actually, what you are getting back is JSON files, but what you are sending to the server is simple. It's not even JSON files. It's just a string representation with the Machina command. Move, rotate, whatever, you know.
Exactly. Yeah, it's amazing. I mean, so cool. Yeah, but one thing that I've actually noticed about, not precisely about this thing. So in the past, I've tried to simulate an ABB robot using the ABB Robot Studio on my own local machine. So what I would do was to have one particular point and have the robot try to follow that single point in time, in real time. One thing that I really noticed is that whenever I would change the point in a drastic way, the command would be sent to the robot, and the robot would do that command and would execute it. So it wouldn't really matter where I put the point while the robot was doing the previous command that was sent to it. So that's something a little bit in terms of like safety issues, that's a kind of a concern. What do you think maybe we could do something about that?
I'm not sure. I couldn't really understand what the problem was, or maybe what the scenario was.
Let's say we tell the robot to go a really far distance, and in the middle we decide that this is how far we want the robot to go. So there's no canceling in between commands, it seems.
Oh yeah, Machina? No, right now there is no such thing. No, because the robot for ABB, for example, the robot basically is locked or is blocked while it's doing an action and it's not really listening to anything else. In order to be able to listen, you have to have, for example, in the case of ABB roles, you have to have multitask, and that is that's a special feature that you have to pay for, and there's like all these other. So it's not part of what Machina, for example, does right now. But hopefully in the future, we will have such an option, yeah.
See, yep. Yeah, thanks again. This is so cool. I mean, it's perfect. I mean, I would say it's a perfect experience.
Wonderful. All righty. If anyone else would like to give it a try, then speak now or hold your truth forever. And if no one is up for it, then I think we may just turn the robot off and do a little bit of social and Q&A.
Oh, I'm just arrived now, I can say.
Yes.
But I like to do this experience, what I'm talking about.
Saeed, sorry, I
Yeah.
didn't. Hi, Saeed. How you doing?
How are you?
I'm doing good. Thank
Sorry,
you.
I was online, but I wasn't like nearby my laptop, but I can't. Sorry.
All right. So, do you want to try now, or do you still don't have access to the laptop?
Yeah. You mean I connect from Grasshopper, or I should, because I should install the components, I think.
It's
But I
all-
can use the Discord from my browser. Yeah.
So you can either do it from the terminal here, or you can do it from Grasshopper, whatever you are more comfortable with. But if you do Grasshopper, you have to use the files that I posted in Discord, because there, I made a couple of changes to the Grasshopper plugin. So you need the more updated version that I just posted.
Well, actually, I need a time. I don't want to waste your time. I try to be connect like, okay.
All right. Then maybe you can try some other day. And this is going
Yeah.
to be, this is going
Yeah,
to be
it's
available.
better. Sorry.
No, no worries. This is going to be available out there very soon. So you will be able to set this up on your own as well.
Okay. Thanks.
All right. Okay, then I'm going to stop. I'm going to close this thing up, and I'm going to stop sharing. Woohoo! I think I'm going to go back to live streaming mode. Sujay, can you use a sensor to get some feedback data from the robot back into Grasshopper? Of course, that's the whole point. I actually have my students at Harvard and some of them at UPenn as well. They are, for example, using Firefly to read sensor data from an Arduino and use that to decide what kind of actions they send to the robot and how do they move it up and down, left, right, how close they are to her surface, etc., etc. So, so yeah, so it's very possible, and that's the whole point. That's why I think Machina is interesting, because it allows you to do this kind of real-time operations. Sherman, you cannot right now create a loop on the bridge, on the terminal. It doesn't have that functionality, but it would at some point. It's not really a full programming language. It's something that looks and feels like a programming language, but it doesn't really have variables, or it has for loops or any kind of those things yet. But if you want to do that, you can actually use Machina inside real programming languages like JavaScript, Python, processing, and all of those. The bridge is installed on the controller of the robot or the control user PC. You install the bridge lives on the computer that is connected via the network to the robot controller. And I think you're thinking of the Kookaburra proxy situation. This is not how Machina works. Machina works, the bridge lives on the computer that is connected via the network to the robot. And actually, the bridge also works for simulation environments. So, for example, if you use ABB Robot Studio, you can connect the bridge to Robot Studio and do the same whole thing and practice with the virtual robot before you go into the real one. I see some feature requests from Sarah. And Sachin is asking if I can connect the robot through cloud to haptic gloves. Yeah. So just like we were using Grasshopper to talk to the server, or just like we were using the front end, the website to talk to the server, you can just send whatever information to the server. So whatever you're controlling the haptic gloves from, you can use that to generate the Machina instructions and then send them to the server and then connect to the robot. The fact that it can be controlled online is really cool. Thank you, Sherman. I think it's really cool too. Safety. Does the UR robot here has software access limit? Yes. And you actually saw that at some point it was rotating too much into itself and it stopped because it detected that it was going to clash. And Kunjalid is wishing me happy Eastern. Feliz Semana Santa to you too, man. And I think that's it. That's most of the questions. All right.
Can I ask a question about the technicalities of the driver that you're using for the UR?
Yes.
So one thing that, so as you may know, I just got my Coupa operation operation certificate. So one thing that I noticed about Coupa is that when we're trying to give it a point to go to, the robot would start at the point and would stop at the next point. And if we want to have it to go through a continuous motion from multiple points, then we would have to set something called an advance, which would tell the program to read multiple commands after the one that is actually being executed. That way, it would have something like a continuous motion. And so does your driver here do something like that, or is it like point by point movement and a back and forth talking with the client outside?
For ABB and for UR, you don't need to explicitly define that you want to have ahead points. So, okay, so a little bit for context, what Arasto is asking is the fact that the robot motion might be jerky, like it goes, let's say we want to trace a square. We probably want the motion to be smooth like this, right? But Arasto is saying what happens sometimes is that the motion is like I go here and I stop, and then I start over again, and then I stop, and then I start. And therefore, the robot basically stops at each point and then accelerates again.
Exactly.
This happens because typically what robots do is that when they reach a target, if they know where are the next targets that the robot needs to go to after that, then the robot is able to smoothly interpolate and create what's called a blending trajectory, so that it doesn't really stop, but it makes like, imagine a car that is like smoothly turning a curve, as opposed to stopping on the traffic light and then turning, you know? So if the robot knows the targets that are coming afterwards, then the robot can create this smooth interpolation between the trajectories. But for that to happen, the robot needs to know ahead of time what are the next targets. If those targets are not in memory, then the robot doesn't know there are those targets, and therefore it programs itself to stop at the target. And then maybe when it receives a new one, then that's when it goes to the next one and to the next one. The way Machina deals with that for ABBs and for universal robots is that because the communication happens fast enough, then the robot already has those targets in memory, and therefore can look ahead and see that there are new trajectories, new waypoints, and it can interpolate smoothly. That provided that you have sent a large enough program that has all those targets. If you don't, then it's going to stop and execute each one of them with an acceleration and a braking. But in ABB and in UR, you don't have to explicitly say, hey, I want you to look ahead at the next target, because it does it automatically.
Mm-hmm. So by the way, are you?
Sorry, Arasto, and that's another problem.
Yeah.
That's another problem when you do, for example, when you run an offline program, right? So when you generate a program, a full program on Grasshopper or whatever, you load that program and you run it on the controller, then it's very easy for the robot to know what all the targets in the future are going to be. But when you're doing real time, it's a bit more difficult because this information is coming all the time. Depending on how you handle that information, then the robot may or may know about the future. So for example, if you write a program, you were asking about the driver. If you write a program that, let's say, is listening for instructions, okay? And then what that program does is, whenever it receives an instruction, it executes that instruction and it waits until that instruction is done to listen to the next one. If you write such a program, then you will never have knowledge about the targets that are coming ahead, because you, the program, you are waiting for that motion to finish before you listen to the new ones. So what's typically good to do is to write programs that can have the possibility of listening to incoming information while the robot is moving. That may or may not be possible depending on the robot. Sometimes robots basically can't listen to anything while they're performing an action. So some techniques around that is like, for example, let me listen to an instruction. But if I know that there are other instructions on the line, sorry, if there's a queue of like several instructions coming in, let me just read them all. I'm going to store them somewhere in memory, and then I'm going to start executing them one at a time. And as I do, I'm going to keep listening to more of those. That is a much better way, because you always have on the robot in memory some more information to work with for the future. I'm not sure if I explained that correctly, but I'm not sure if that was clear, but it's a way of dealing with the problem of real-time information coming in.
Oh yeah, it was perfectly. You answered exactly what I wanted to hear. Yeah. Thanks.
And that is also a problem with techniques that involve real-time control with, for example, replacing variables that live inside of the controller, which is, for example, what I think the Kookaburra proxy framework does. Instead of receiving actions, what you do is you override the value of certain variables that live in the controller. And depending on how many of those variables you have, then depending on how many, maybe the robot knows information about the future trajectories, or maybe it doesn't, if you're only setting one variable for the target every time.
Well, yes, well, to be honest, I guess it's exactly like that.
Yeah.
It is something like a program that switches between different scenarios, it's more like an if, else, if, something like that.
Mm-hmm.
And for every change on one of the variables that you would change using Kookaburra proxy, the Kuka driver program would switch between one of the scenarios and does something.
Mm-hmm.
And what I have seen in some of the drivers that have actually been developed for Kookaburra proxy is like single points. There are exactly single points that are being changed using that Kookaburra proxy from outside the robot environment.
Yeah, that is, I know, I feel you exactly, and that's how Machina was born. So the very version 0.001 of Machina for ABB was using that technique. But that proved to me limiting very soon. And that's why I changed and I improved it to something that has a buffer of memory coming in. And it's not replacing variables, because that also, in my case, it was a little bugging as well. Sometimes the variables were just not correctly placed.
I see.
And that's why I thought, back in the times when we've had these conversations, I thought that the way to go would be to use the Kuka Ethernet KRL. I'm not even sure what it is, but I thought that would be the way to actually implement something that is a bit more stable and exchanges information dynamically better.
Yeah. Yeah, I guess it's called EKI, and it's a package that you have to buy from Kuka, and most of the time it's expensive.
I know. ABB also, you have to pay to have Ethernet communication with ABB robots. But it's if you want the real deal, you gotta pay for it, man.
Yeah.
No one gives you anything for free these days.
Yeah, exactly. Nothing is. Yep. Thank you so much.
All right.
Amazing.
Okay, I think with this, we're going to call it a day. I'm also going to start my Saturday. So thanks, everyone. I hope you had fun. And we'll hopefully see you back next week for some more live streams. All right. Thanks a lot.
Thank you so much.
Thank you, Salvador. Bye.
Next week.
Bye bye.